Question 3c. A household iron is cooling in a room of constant temperature 22 degrees Celsius. At time t minutes, its temperature T decreases according to the equation d capital T dt is equal to negative K multiplied by capital T minus 22, where K is a positive constant. The initial temperature of the iron is 80 degrees Celsius and it cools to 60 degrees Celsius after 10 minutes. Part 1. Verify that capital T equals 22 plus a e to the power of negative kt is a solution of this equation where a is a constant. This question will be answered by solving the differential equation d capital T dt is equal to negative k multiplied by capital T minus 22 by separation of variables. So I'm going to divide both sides of this equation by capital T minus 22 and multiply both sides of this equation by dt. So we have d capital T over capital T minus 22 is equal to negative k dt. The next step is to integrate both sides of this equation. So we have the integral of d capital T over capital T minus 22 is equal to the integral of negative k dt. And that gives us ln of the absolute value of capital T minus 22 equals negative kt plus the constant of integration c. I'm going to call this equation number 1. Next, we're going to find the constant c using the initial condition. So we know that when t equals 0, the temperature of the iron is 80 degrees Celsius. So I'm going to substitute t equals 0 and capital T equals 80 into equation number 1. So from equation number 1, ln of 80 minus 22 is equal to c. Therefore, c is equal to ln of 58. Next, we're going to find the constant k by substituting t equals 10 and capital T equals 60 into equation number 1. We know that at the 10-minute mark, the temperature of the iron is 60 degrees Celsius, so that's where these values come from. So from equation number 1, ln of 60 minus 22 is equal to negative 10k plus ln of 58. And 60 minus 22 is 38, so we have ln of 38 is equal to negative 10k plus ln of 58. Rearranging this formula to make 10k the subject, we get 10k is equal to ln of 58 minus ln of 38. Dividing both sides of this equation by 10, we get k is equal to 1 over 10 multiplied by ln of 58 minus ln of 38, and that equals 0.04229, correct to 4 significant figures. And the value of a will be found in part 2. Part 2. Find the values of a and k. From part 1, ln of the absolute value of capital T minus 22 is equal to negative 0.04229t plus ln of 58. This was the value of k that was found in part 1, and ln of 58 was the value of the constant of integration, also found in part 1. Now we need to make capital T the subject of the formula. Now we have an ln here, so we can remove this ln or cancel out the ln by raising both sides of this equation to the base e. So we have e of ln of the absolute value of capital T minus 22 is equal to e to the power of negative 0.04229t plus ln of 58. Notice that this index here is in brackets. Also note that capital T is greater than or equal to 22, so we no longer need the absolute value sign around capital T minus 22. Now e and ln are inverse operations, so they'll cancel. So we have capital T minus 22 is equal to e to the power of negative 0.04229t multiplied by e to the power of ln of 58. And that's using index laws. Now e to the ln of 58 is just 58 since e and ln are inverse operations. And then adding 22 to both sides of this equation, we get capital T is equal to 22 plus 58 multiplied by e to the power of negative 0.04229t. Therefore, a is equal to 58. And also note that 22 plus 58 is equal to 80, which corresponds to the initial condition where the iron is 80 degrees Celsius at time t equals 0. Part 3. How long will it take for the temperature of the iron to cool to 30 degrees Celsius? Give your answer to the nearest minute. Using the equation we found in part 2, we need to solve for t when capital T is equal to 30. So substituting t equals 30 into the equation, we have 30 is equal to 22 plus 58 multiplied by e to the power of negative 0.04229t. Subtracting 22 from both sides, we get 8 is equal to 58 multiplied by e to the power of negative 0.04229t. Dividing both sides by 58, we get 8 over 58 is equal to e to the power of negative 0.04229t. Now to cancel out this raising to the base e, we take the natural logarithm of both sides. So we have ln of 8 over 58 is equal to negative 0.04229t. So we're going to make t the subject of the formula now. We're going to divide both sides by negative 0.04229t. So we get t is equal to ln of 8 over 58 divided by negative 0.04229. And that equals 46.843 minutes, which is equal to 47 minutes, correct to the nearest minute. Here are the notes from the marking center for this question. Bear in mind that this question was answered by solving the differential equation in line with the current syllabus. That is the syllabus from 2017 onwards. So for part 1, this was done well, although many tried to solve the differential equation instead of verifying that the given expression was a solution. So in the syllabus pre-2017, there was no solving of differential equations. All that was needed was to differentiate capital T equals 22 plus ae to the negative kt and show that it satisfies d capital T dt is equal to negative k multiplied by capital T minus 22. So for part 2, the answers to this part were plagued by arithmetic and transcription errors, so take care when setting your working out. Now, common errors were a equals 80 and replacing both capital T and t by 60 in the equation relating to time 10 minutes. And for part 3, candidates should be encouraged not to round early in their calculation. So ideally, leave, for example, k in exact form. Now, in my solution, I rounded k to 4 significant figures, which for most intents and purposes is sufficient. Rounded values of k should not be used in later calculations. Many interpreted how long to mean how much longer, i.e. after the first 10 minutes. Correct answers that were not rounded to the nearest minute were not penalized.